Hey, chemistry lovelies. I miss you guys so much. I know this is weird for everybody, but we're going to get through it the best we can. I just wanted to, I'm putting a notice on Canvas about starting at the beginning of this objective. So hold on to the mole conversions, and we're going to go to phases first, as you can see here. And so in your admit slip, you have a set of notes that looks like this. And so I wanted to go over them with you. So if you need to pause this to get your admit slip out. So what we're doing is talking about phases of matter first, as it says over here. This is what we're going to do first. And I know you've seen phase changes before. We're just going to go a little bit more in depth. And I know you've already read about the ideal gas law on the Khan Academy, the CK12 and whatnot that I've already sent you and you had in the first part of your notes. So we're going to dive straight in here. Okay. So we know temperature can change a substance. Oh, by the way, if you have not done the boiling water and temperature formative assessment probe on the discussion thread, you need to do that first. Okay. So we know that temperature can change the phase of a substance, but now we're hearing that that pressure can do that. Okay. So I wanted to show you this picture. Here we have a gas. Okay. And it's being completely sealed. Okay. And then you see it as the pressure comes down on it right here. It changes into a liquid, and then it changes into a solid. So that's kind of giving you an idea of the size of the gas cloud, what it would be if it was solid. Okay. And so this is called an isothermal process. Okay. Where the temperature is constant and the pressure is changing. Okay. All right, so now let's take a look at the difference between heat and temperature. So you should have read, I believe it's on the Khan Academy website, about the average kinetic energy. And remember, kinetic energy is the energy of movement. And so we are going to talk about the difference between heat and temperature. So heat is transferred to an object. This would be like a stove to a pan, okay, for the most part. So we're talking about an energy transfer. And it does depend on the mass. And that, depending on mass, is how much is transferred and how fast or slow it's transferred, okay? And can cause phase change. Okay. All right. We measure this in joules. Okay. So let's talk about temperature. This is basically, in the simplest terms, how hot or cold something is. Okay. It is an object's, just strictly definition here, an object's average kinetic energy. Average kinetic energy of the particles. Okay, so where this one depends on mass over here, this one does not. Okay, and we can measure temperature. I'm sure you obviously know that we can measure it in Fahrenheit degrees, we can measure it in Celsius degrees, and then we can also measure it in Kelvin. Okay, now let's talk about how these two things are similar. What do they have in common? Okay, they have a direct relationship with their objects. So, and when I say direct relationship, I mean not opposites, okay, not inverse. I'm talking about direct. And they both have to deal with kinetic energy. And they both have ways to measure. Sorry, squeezing that in there. Measurements. Okay? All right, and so I want you to go through and read those examples. Now we're going to switch to the back page here, and let's talk about the temperature scales. Okay? If anybody knows anything about Celsius, oh, whoops. Okay, Celsius, and then I'm going to compare it to Kelvin over here, because Celsius and Kelvin are what we are supposed to use in the science classroom. Okay, all right, so absolute zero, when we say absolute zero, that actually means 0 in Kelvin, but for Celsius it means negative 273. Now, if we're looking at the freezing point for water, you should know that Celsius is 0. And what's it supposed to be for Fahrenheit? 32, right? Okay, so the freezing point for water in Kelvin is going to then be 273. And then the boiling point for water in Kelvin is 373. And look at the relationship here, there's 100 degrees difference, so what's this one gonna be? 100 degrees. Okay? All right, now let's talk about conversion. Okay, if we're going from Celsius to Kelvin, we are going to add 273. Okay, and then if we're going from Kelvin to Celsius, we are going to, you guessed it, subtract 273. Okay. All right, so let's move on down to the phase diagrams. And I know that you've seen on the matter guide that we had before we left, the different phases. Okay, and at this point in class, I would be asking you to call out the different phases. And we're not going to worry about plasma right now. We're just going to worry about the ones we're used to. Okay, so these are, like this one is a phase change in carbon dioxide. Okay. Now, let's talk about, on these diagrams, you see the critical point and you see the triple point. So over here, I want you to write what the critical point is, and it is between a liquid and a gas. It is the point right there where we go from liquid to gas. The triple point is where all three states coexist. So at the triple point, you literally can find right here something, the solid, liquid, and vapor or gas, same thing. Okay, all exist together right there, the triple point. Okay. All right. So this is the phase change for carbon dioxide, and no, you do not have to memorize that. I just wanted to show you the difference in this one versus the difference in the phase diagram for water. You see where the critical point is and the triple point is, versus this is all solid right here, this is all liquid, and this is all gas. Okay, So I want you to study that phase diagram. And I had an activity I wanted to do in class for phases, but we will have to work from, do you have your phase change handout from class where you had to do the front page, or are they in the turn back box at school? So maybe you have yours. I hope you do, because we're going to be talking about that. But if not, it's okay. You can just take a few notes, okay, when we get to that part. So sublimation, and this is the point where I'd be asking you, what is sublimation, okay? And the opposite of sublimation, before I get into it, is called deposition. Okay? So sublimation is a transfer from solid to vapor or gas, and it skips the liquid form. So it skips this whole liquid phase. It goes straight from a solid to a gas. Okay? And heat and pressure allow for this. Both. Heat and pressure. So sometimes pressure can do it. Sometimes heat can do other phase changes. But for sublimation, we need the heat and the pressure. And I would ask you what kind of reaction this would be. And it's going to be endothermic. And we demonstrated that in the lab before we got out for spring break. When you feel that test tube or bag or whatever you're dealing with is cold instead of warm. Okay, so this is going to happen below the triple point. And I would be asking you your thoughts as to why that is the case. And it is the case because we're skipping that liquid phase. So as you can see, you can go straight from a solid to a gas at the triple point because that's where they all coexist together. So an example I want you to know for this one would be dry ice. And we've all heard of dry ice before. If any, I would be asking you what this is, but it is, go ahead and tell you, it's solid carbon dioxide. Okay? And so at room temperature, and regular pressure, it sublimates into CO2 vapor. Okay, so I want you to, for the next video, get prepared with something else to write on, because we are going to talk about this handout. And if you don't have it, that's okay. You just take a few notes from it, okay? All right, I'll see you for the next video.